Hello and welcome back to our series on beginning app script for HR brought to you by Prairie HR Solutions. My name is Jake Finger, Principal Consultant here at Prairie HR Solutions. And in today's video, I would like to talk about conditions, checking conditions through if statements as well as switch statements. So if we think about conditions, we run into conditional if statements, or at least the concept, all the time in our field. Say we have a manager and in a performance review. And then, they've got to turn in a performance review by a certain date so we can record it, do merit pay, or, make sure PIPs are done or whatever. So we're running, if we think about it, we're running an if statement. We are checking to see if that manager has completed and submitted the performance evals. If they have, then we do something such as, thank you. But if they haven't, then we have to do something else. And then we have to check, well, why? And then depending on that condition, the result of that, we would do something else. So we live in a world of conditional if statements without knowing it. And when we think of if statements in Google Apps Script and JavaScript, they are operationally based. And our JavaScript or our code is also operationally based. We are thinking operationally in steps. And what an if statement does is it checks the condition of something like say a variable. And if it meets that criteria or that condition, it returns what's called a Boolean value. And that Boolean value is either going to be true or false. If it's true, then the condition is satisfied and it can run a block of code. If it's false, then it just goes on. And the syntax, if you'll notice, I already started this. So I took our old code for those of you who have been following along. I took it and placed it in our reference and created a function here called cond_if with some variables. And I also put in our syntax. So let's talk about the syntax. So the syntax, or how the if statement is actually written, is you declare it with an if, and then you have the condition. And our condition takes certain comparison, they're called comparison operators. And our comparison operators can be strictly equal to, or less than equal to, greater than, whatever. And I'll make a list of these one here in just a second. But if this condition here is true, then it runs a block of code. If it's false, if it doesn't meet the condition, then it goes on to the next statement. If there isn't a next statement, then what happens is we can give it an else statement, which means that if nothing above this is true, we just want you to do this. If you don't have an else statement, then what ends up happening is nothing. It just doesn't do anything. It runs the code, but it doesn't produce anything because there's no code telling it to do anything, if that makes sense. And let's look at that. Let's write ourselves an if statement. Let's do if our condition, let's check to see if this variable job title strictly equals recruiter. So let's do job title. And we want to check to see if that is strictly equal to recruiter. And if it is, then let's have it produce a log. Now, this code essentially can be any set of instructions. So we could copy and paste all of this, this let data, let employee, all that, place it in here. We can have it do anything. We can even have it run a function if we wanted to, or call a function. But for now, let's just have it log something. Oops. And what we'll have it log is, yes, I am. Okay. And now if we were to run this, let's make sure we do the conditional if. If we were to run this, you'll see that it is producing the instructions that we told it to because this is true. Now, say we wanted to put this in as, I don't know, accountant, and then we run it, nothing would happen. You'll see that it started, it completed, but we didn't tell it to do anything if everything was false. So to do that, we would give it an else. So when all else fails is the best way I think about this. Do this code. And we'll have it log, and say, no, I am not. So now when we run this, we're giving it something to do if everything is false, and it will run that code. So let's look at, instead of using this job title, let's try and check this variable. So let's go job titles, and let's pick HR analyst. Okay. So what we're checking here is we are checking if the variable job titles is strictly equal to HR analyst. Now I want you to think about what this is going to return. Is it going to return true and produce this log, or is it going to return false and produce this log? It's going to be false, and it's going to come back as no, I'm not. And you're going to say, well, hold on a second, because HR analyst is right there, and we're checking to see if it's, equal to this job titles. But we're not checking to see if it's somewhat equal to. We are checking to see if it is strictly equal to. And that's where we're going to run into. That's where we may run into issues when we're checking conditions, because this variable here is all of these values. This is a list. You'll notice that it is encased in parentheses, which means it's just a simple list. If this was a array with the square brackets, we would have to select the index, and we could do that. So let's actually try that for the sake of demonstration. So HR analyst is 0, 1. So if we want to check this now array at 1 to see if the index number 1 is HR analyst and we run it, it is yes, I am. But when we had just the list, what this variable was saying was this variable was all of these values. So in order to make this true, we would have to ensure that we are checking all the values. Now, we could go through and do that, or we could look at if we really needed to make it strictly equal to. So when we do strictly equal to with these three equal signs, we are saying that everything about HR analyst is the same that we're looking for. What I mean by that is the capitalization is the same, the spacing is the same, everything about it. It's a string. It must be exact. And that's the reason why we're triggering this, because in job titles, it's not just exactly that. It is all of this. So what we can do is, instead of having a strictly equal to, we can simply loosen our grip by making one equal sign. And that one equal sign is saying, it's not, it gives it leeway. There are certain levels of the equal sign, but to keep it simple, three equal signs means that it is strictly everything must be exact, identical, no questions about it. It is what it is. Now, if you have one equal sign, what you're saying is this is kind of what we're looking for, but it's okay if it's not exact. And when we hit run now with just this one equal sign, it's going to come back as yes, I am. And the reason is it's saying, okay, well, it's not exactly that, but it's kind of that because we have HR analyst in it. And so we're going to count it as true. Now, the tricky piece about this, I typically never use just one equal sign. And the reason I never use one equal sign is because there are instances to where we could just do HR and run it, and it's going to come back as yes, I am. And we can actually come back and just say H. I don't know if this is going to go down far enough. It probably will. Yes, I am. What's going to end up happening is one equal sign is so open that it almost makes the condition of the if statement when it's dealing with strings impractical. So either take your list and turn it into an array like we did and then focus on the individual index, or just leave it as strictly equal to. So let's talk about those operators here. Let me give a reference for our operators. Let's go comparison operators. Now our comparison operators are right here. They are what we use to check. So we have obviously 3 equal signs. We'll say strictly, ooh, that's bad spelling, strictly equal to. And this is really important when we're dealing with strings. Now we can just use 1 equal if we're dealing with a number like 2 or 4 or 5, or we are checking an actual Boolean value. Like we're checking to see if this statement returns true. And if it does, then we can say, let's actually change this. Let's change this to a Boolean value to simply true. And you'll notice a Boolean value is lowercase. So this could be true or false. And then what we can do is actually come in here and say true like that, run it. And it comes back, yes, I am. So really when we're thinking of strictly, it is primarily important with string. And then what we have is this little thing, which is an exclamation point and 2 equal signs. And what this is not equal to. So if we were to take this and say recruiter, well, looking at this code, this is going to be true. But if we were to replace this and say that if job title is not equal to recruiter, then say yes, I am. If not, go else. So this is going to run the same way, except it's going to skip over that initial code because that condition is not met. Job title does equal recruiter, and we're checking to see if it does not. So that's not equal to. And then we have our numeric. And our numeric, of course, are the little gator mouse. That's what I was taught in school, little gator mouse. This is less than. And then we have less than or equal to. Oops. Less than or equal to. There we go. Less than or equal to. And then the same exact way here, greater than. And then we have greater than or equal to. So these are our comparisons. And then we have what we call our logical operators. So we can run into situations to where, in fact, we run into these situations quite a bit dealing with data, that we want to check if job titles equals HR generalist or HR analyst or benefits coordinator. And we can do that by simply putting in 2 slashes. This is or. So we could come in here and say this is strictly equal to, or job title does not equal, something. So this checks this condition or that condition. And then we have and. So if we change this to these two ampersands, then in order to make this true, this condition has to be true and this condition has to be true. To where it's or, if this was or, it was just either or. And then there's some other logical operators that I don't want to get us confused with. We may encounter them in the future videos, but right now I think this is good here. So what if we had another set of ifs? We wanted to check, okay, if job title is recruiter. Well, actually, let's change this. Let's change this back to CHRO. So if we just left it at this, then it's going to produce no, I am not. But what we can also do is, instead of just going straight to an else statement, we can do another if condition. So we can say else if job title is strictly equal to CHRO, then I am the CHRO. So now let's run this and see what happens. So we run it. I am the CHRO. Because what's happening is it goes through this first condition. That came back false. I'm not even worried about that. It's going. I'm going to the next one. Else if this condition is true, which it is, then it runs this. And then our code stops. This if statement stops as soon as it gets a true value. If it doesn't get any true value, then it just runs the code for the else. But once it hits true, it stops. So you can imagine situations, especially if we're dealing with, complex decisions like a decision tree, and we're having to drill down to, well, we have just a lot of else ifs. Our else ifs can get pretty long. And if this is running through checking every single line and then stopping, it can slow down our code. It can slow down our code significantly. Or if you have an if statement embedded in our if statement, which is called nested if statements, this can slow down our code to a point to where it's noticeably slow. So if you do end up having a lot of if statements inside your code, and this is just, it just seems to be going on forever, and you have like 10 else if statements, you really should consider using something else. So let's create ourselves another function. And let's call this function condition switch. And a switch statement is actually cleaner to a degree than an if statement, because you'll see that we have quite a bit up here, and we're running this until we hit true. And then we'll go back and run it again until we hit true. And if we have a lot of else if statements like before, like I was mentioning before, it is particularly useful to use an switch statement, because a switch statement evaluates a single expression against possible values. So it can be thought of as taking all of our else ifs and rolling it up into one. So let's actually create something. I'll create something different here. Let me give a new variable here. Let me copy it over here. Actually, you know what? We'll do something very simple. I'll roll this into this. So let's do let day. And what we'll do is we'll do new date. Now, what new date is, we'll get into this, trust me. The new date will is essentially saying we want to get today's date. And then we want to get the day of today's date. So essentially, if today is Friday, then day is going to equal Friday. So now we want to check to see if the day, and this is going to come over as a number, so it's going to be 0, 1, 2, 3, 4, 5. Probably should write that in here. Returns the day as a number. So 0 is Sunday and 6 is Saturday. So it's going to come to us like that. So we're not going to be able to say Sunday. We're going to have to check just that number. So the way we write a switch is we start off by declaring it is going to be a switch. And we're going to want to write the condition. And that condition is going to be the variable. That's what we're checking. And then instead of writing, strictly equal to, what we have is what's called cases. Because we're taking all of our else's and rolling it up. So this else if is a case. If we had another one, it'd be another case. So let's add our square bracket or curly brackets in here because we want to check these cases to run a certain code. So our first case is going to be 0. And if it's 0, then we want to run a log. Let's logger log I am Sunday. Now this is running whatever day of the week this is. So if I run this tomorrow, I'm going to get a different result. The thing that's different about this is we have to tell it to stop once this case returns true. Once it comes back as, it is 0, we have to tell it to stop. So we do that by saying break. Now, if it's not 0, then we have to give it something else. So let's do case 1. And if it comes back as case 1, I am Monday. And then say today is Thursday. So I want to do one with Thursday, and Thursday would be 4. And we want to log Thursday, if I can spell it right. And we need to add our break in here. You'll notice the difference is we have a break, and I'll put the syntax up here. We have a break after every piece to tell the code to stop running because it doesn't need to check anything else. It won't stop automatically. And then what we need is our default. And that is if we don't have anything. If none of these come back true, we want to give it a default case. And then we want to say, just put it this way. So if it doesn't come back as of day of the week, it's going to return I don't exist. So now if we were to run this, of course, if we were to select the right function and run this, it's going to come back as Thursday. Now today, as I was mentioning before, today's day of the week is Thursday. So what it's doing is it's getting the new date, which the way Google AppScript returns days is numerical. So it is 4. It's taking 4 and storing it in day. And then it's taking that variable, and instead of checking individual conditions, it's saying, I'm going to run all of these cases. And until I find the right case, or when I find the right case, I'm going to do that. And if I don't, this is the action that I'm going to take. So say we were to change this to 3. Now remember, today is Thursday, and we run it, it's going to come back because that doesn't actually exist. And the reason why I didn't log it is because I forgot to put log. As we run it now it'll log it out. So the syntax for our switch statement here is switch, and it's not necessarily a condition, it's what we call an expression. And oftentimes this expression is a variable. And then what we have is our curly brackets, because when we hit true, we want to run some code. So then we have case value 1, and then code to run. And then we have break, and then case value 2, colon, break, on and on and on until we get to the end, and then we create a default. And then that default runs some code, and then we break to end it. Now, the good thing about switch is, believe it or not, switch is a lot cleaner. It's a lot easier to read, because if we got into an if statement and then it's like, ooh, I'm a recruiter, well, then we can drill down even further and do what's called a nested if, which would end up looking, which would then end up looking like another if statement here. So you can see that it can get actually pretty complicated. But with a switch, it's a lot cleaner. And believe it or not, it's a lot faster. So if you have a lot of conditions to actually check, try to use switch. Now, the one thing switch can't do is check for equal to, greater than, or less than, or not equal to. Switch only compares to things that are strictly equal to. So if we were trying to check if the job title is less than 0 or whatever, then we wouldn't be able to use switch, because it doesn't work that way. It just doesn't check it. But if you're checking strictly equal to, which when we think about what we do with our arrays and our data, we have been using strictly equal to's a lot, so we can get away with using switch. And the other thing that we can use switch for is in our HTML files. Because when we start writing our code can become incredibly long. It can become incredibly complex. And there's a time to just get the thing functional and call it good. But then what we lose is its readability. Our code should read like a book. And when we start hitting HTML and we start diving into creating our HTML pages, those codes can easily get so complex to where you're just left scratching your head like, where am I? What is this thing doing? And when we write our conditional switches in the JavaScripts on those pages, it assists with keeping it clean, because you can see that this is a lot easier to follow along with than our if statement. And we'll use both throughout our future videos. I'm going to end this video here. Our next video is we're actually going to use another service. Right now, we've been working with the spreadsheet app. What I would like to do is come over here to our spreadsheet. I would like to create a custom menu button up here. And this whole thing is called our UI. And I would like to create a custom menu up here to run a function. So we can run a function by a trigger, or we can simply have a menu item that we can click a submenu and it would then run that function. So until next time, I hope you enjoyed this video and I hope it was informative. And I hope to see you at the next video. Till then, take care.